Hello students, welcome back to the 8th video of this playlist. In this video, we will be solving question number 8 from the recent past paper of Pure Mathematics 2, which is the May 2024 P2 paper. So let's get started with question number 8. So at first, part 1 of question number 8. Here the question is asking to solve for x greater than 0 less than or equal pi. The equation 5 sin x tan x plus 13 equals to cos x, giving your answer in radians to 3 significant figures. Okay, so basically this is from trigonometry. We have to solve this trigonometric equation, and the range for x, it is given. The values for the possible values for x should be between 0 and pi. Okay, so to solve this equation, at first let's simplify this one and make it in terms of a single trigonometric ratio. So 5 sin x tan x there, so we can write tan x. Okay, we can write tan x as sin x over cos x. Okay, part 1. For part 1, okay, let me change the size of the ink. Okay, so 5 sin x times sin x over cos x, and then plus 13 equals to cos x. So we have to simplify this trigonometric equation at first, and we will represent it in terms of a single trigonometric ratio. So you will get 5 sin squared x over cos x plus 13, this is equals to cos x. Okay, so multiply both sides by cos x, so you will get 5 sin squared x plus 13 cos x equals to cos squared x. Okay, now use the identity. Sin squared x plus cos squared x, this is what? 1. Okay, so sin squared x can be written as 1 minus cos squared x. Why I am doing this? Because we need to represent the given trigonometric equation in terms of a single trigonometric ratio. For that, I'm converting sin squared x to cos squared x. Okay, so cos squared x on the right hand side. Now multiply the bracket. So 5 times 1, and then 5 times negative of cos squared x. So this is negative 5 cos squared x plus 13 cos x. Take cos squared x, okay, keep cos squared x on the right side, so it will remain positive. Okay, now take all the terms to the right side. So this is negative 5 cos squared x. If you take it to the right side, it will become plus positive 5. So 5 plus 1, it is 6 cos squared x, and then 13 cos x, it will become negative 13 cos x. It was positive 5, so if you take it to the right side, it will become negative 5. So this is equals to 0. So now we have a quadratic trigonometric equation now, right? So in that case, we will use middle term. We will do middle term factorization in this case. So 5 times 6, it is 30. So 10 times 3, it is 30. So we can use the middle term as 6 cos squared x 10 times 3. So negative 3 cos x negative 10 cos x plus 5 equals to 0. If I am not wrong, this is basically the equation. 6 cos squared, it is negative 5. Okay, no problem. 15 times 2, also 30, isn't it? So negative 15 cos x plus 2 cos x. Okay, it will be negative 15 cos x, negative 15 cos x plus 2 cos x, and it will be negative 5. Now is it perfect? Exactly. Negative 15 cos x plus 2 cos x, it will give you negative 13 cos x. Okay, exactly. This is fine. Now we can take 3 cos x common from there. So if you do so, you will have 2 cos x minus 5, and from there we can take plus 1 as common. So if you do so, 2 cos x minus 5, it remains as the factor. So either cos x equals to negative 1/3 or cos x equals to 5/2, which is 2.5. 2.55 is greater than 1, and we know that cosine has maximum value of positive 1. So we will ignore this solution. Okay, this value of cos x. Okay, so only possible value for cos x, it is cos x equals to negative 1/3. So now get the values for x using the cast diagram. Okay, consider the cast diagram on the right hand side. This is the cast diagram. So the first quadrant, it is all positive. Second quadrant only sign positive. Third quadrant only tan theta positive, and then fourth quadrant cos theta is positive. Okay, so the value for cos theta, it is negative. So that means if you consider the range of x is from 0 to pi. Okay, it's from 0 to pi radian. Okay, we will consider this range. Now get the value. Use your calculator, take your calculator to radian mode, and then find cos inverse of negative 1/3. So basically you will get 1.91. It gives okay, it's not a straight line, it is 1.9106063323. okay, 236. Okay, this is one possible value for x. Another possible value for x we have to find out using the cast diagram. So basically 1.9106, if you convert it to degree, you will see that it is basically an obtuse angle, and it lies in the second quadrant. Okay, so let's figure out the acute angle. So acute angle is basically, this is the acute angle, the theta, which is pi minus pi is basically this whole angle. This is whole, it is pi radian, right? So from pi radian, if you subtract this 1.9106332236, you will get the theta. So let's do that. So this is pi is 3.1416 minus the answer that would give you the value for the theta, the acute angle, which is 1.230966764. Okay, so since the range is from 0 to pi radian, so there is only one possible value, which is 1.91, because if you consider this quadrant and this quadrant, sorry, not this quadrant, because in this quadrant cos theta is positive. If you consider this quadrant, it is basically greater than pi radian, so it's not acceptable. Okay, because it lies outside the range, given range for x. So the only possible value for x, up to how many significant figures they wanted? 3 significant figures. Okay, up to 3 SF, we can write 1.91 radian. This is up to 3 significant figures, and that's the answer for part 1 of question number 8. Fine. Okay, next is part 2 of question number 8. So here the question says the temperature inside a greenhouse is monitored on one particular day. The temperature 8 degrees Celsius inside the greenhouse T hours after midnight is modeled by the equation H equals to 10 plus 12 sine KT plus 18 degree, where T is greater than or equal 0, less than 24. Where K is a constant, use the equation of the model to answer parts A to C. Okay, so given that the temperature inside the greenhouse was 20 degrees Celsius at 6 AM and K greater than 0, less than 20. The range of value of K should be between 0 to 20. Okay, so part A here is asking to find all possible values for K, giving each answer to 2 decimal places. Okay, so we need to find out the possible values for K, giving the values to 2 decimal places. Okay, so to find out the value of K, we will use this information. They said at 6 AM. That means 6 AM means at T equals to 6, because the time is measured, is being calculated after 12 midnight, right? So for part 2a, we know when t equals to 6, the value for h, it is 20. Is it 20 or something else? It's basically 20. Yeah, exactly. It's 20 degrees Celsius. Okay, 20. So we will substitute these coordinate into the equation, into this trigonometric equation. So the trigonometric equation, it is 10 plus 12 sine kt plus 18. Okay, so 10 plus 12 sine kt. So 6k plus 18 plus 18 degree. This is equals to 20. Okay, let me recheck whether it is perfect or not. 10 plus 12 sine 6k plus 18. Perfect. Okay, now take 10 to the right hand side, so you will get 12 sine 6k plus 18, that much degree, it is equals to 10. Okay, so you will get sine, now divide both sides by 12, so 6k plus 18, that degree equals to 5/6. Okay, so 6k plus 18, this is equals to sine inverse 5/6. So sine inverse 5/6, remember your calculator should be in degree mode because the angle, it is in degrees. Okay, to 56.44269,024, that much degree. Now we have to consider the cast diagram to get the possible values of sine theta. Okay, so the first one we got, this is basically the acute angle, the principal angle, we can say this is 56.44 degree. So we know that sine theta is positive on the first and the second quadrant. So on the second quadrant there is another possible value for k. But before you find out the values of k, you should keep in mind that the range of value, the possible value for k should be within 0 to 20. It's given in the question. It should be between 0 to 20. So we will consider that given information. Now one is 56.44269024, another one is 180 minus the principal angle, 180 minus theta. So that would give you, that is 180 minus answer in the calculator. So 123.5573 0.8 degree, that much degree. Okay, so let's figure out the value for k. You will get at first 56.44269024 minus 18 divide 6, that would give you 6.407. okay, 6.407111504. This is one possible value for k, so it is within 0 to 20, right? And another possible value for k, it is basically 123.5573098 minus 18 divide 6. So this is 17.59288,497. This is another possible value for k. So we can see that the greater value for k, it is pretty much closer to 20. That means if you consider the further possible value for sine theta, okay, this is 0, 180, 360, and again you will get 360 plus theta. So 360 plus theta is 360 plus 56.44 something minus 18 over 6, it gives 66.406, which is greater than 20. So that means the further values of theta, these values will give the value for k greater than 20. So we will not consider any further values of theta. So the only possible value for k, okay, so the possible values for k here we found. So k equals to 6 point, the question has asked to write to 2 decimal places, so 6.41, or the value for k, it is 17.59. it is up to 2 decimal places. That's it. So we got the possible values of k, 2 possible values of k up to 2 decimal places. That's what part A has asked for. Fine. Okay, next is part B. So in part B, the question says given further that k is greater than 0, less than 10. Okay, so part B is asking to find the maximum temperature inside the greenhouse. Okay, so we need to find the maximum temperature inside the greenhouse. Okay, so basically, if you consider the equation for the temperature within the greenhouse, it has 10 plus 10 is a constant, plus 12 is a constant, but sine kt plus 18 degree, it is basically variable. The value of sine kt plus 18, it varies from -1 to +1. So that means the maximum or the minimum value of the temperature inside the greenhouse, it is dependent on the value of sine theta. So since they are asking for the maximum value of maximum temperature, so when sine theta is maximum, the temperature, that is h, will be maximum. So the maximum value of sine theta, it is 1, +1. So the maximum temperature is 10 plus 12 times 1, that is 10 plus 12, which is 22 degrees Celsius. Okay, so for part B from question 2, okay, from question 2 part B, the answer would be the maximum temperature, it is 22 degrees Celsius. That's it. That's the answer for part B. Fine. Okay, next is part C. In part C, the question is asking to find the time of day at which this maximum temperature occurs. Give your answer to the nearest minute. Okay, so we need to find the time of the day when this maximum temperature, that is 22 degrees Celsius, it is occurring. Okay, so remember in part B, when we did consider the maximum value of h, we basically dependent on the the value of sine theta. So the value, when the value of sine theta is 1, +1, we will get the maximum value of h. So we will just equate sine kt plus 18, this is +1 when h is maximum. So for part C, when h is maximum, sine kt, the value for k, we will consider the value of k that is between 0 to 10, because the question said it is from 0 to 10. So this is 6.41, if I'm not wrong. Yes, 6.41. So 6.40 ... I'm taking the exact value, kt plus 18, this is 18 degree, this is equals to +1. The value of sine theta should be +1. Is it kt plus 18? Yes, kt plus 18. Okay, so 6.40 something plus 18, it is equals to 1. Okay, now get the value for t. 40 ... t plus 18, this is equals to sine inverse 1. Sine inverse 1, sine 0 degree is 0, sine 90 degree, it is 1. That means 90 degree is one of the possible value. Sine 90 degree is 1. Another one is basically, we know that the graph of sine theta, it repeats after each 360 degree. 90 degree plus 360 degree, that would give you 450 degree. Okay, so I think there are a lot of possible values for t, but we have to consider within the range, given range. The value for t, it should be between 0 to 24. So we will consider that range while finding the value of t. Okay, so let's find out the value of t. 90 minus 18 divide 6.40. What's the exact value? 6.4071. 6.40711,504. Okay, so if you divide, you will get 11 point. It gives 11 point. Okay, 11.23750,698. Okay, and for 450 degree. Okay, 450 minus 18 divide 6.40. The exact value was 6.40711,504. So that gives 67. Okay, 67 is greater than 24. So let's ignore 450 degree. We will ignore. So only possible value for t, it is 11.2375 something. So if you convert it to minutes, so we have to multiply it. 11.23750,698. We have to multiply that value by 60, because in 1 hour it is in hours. This is in hours. So if you convert it to minutes, we have to multiply it by 10. So you will get 674.2504,188, that much minutes. So the question said we have to say it to the nearest minute. So to the nearest minute, we can say 674 minutes. So 674 minutes will be what time? So at 660 minutes, it is basically 11 hours. So at 11, so 660 minutes, 660 plus 14, so 11:14 a.m. or you can say in the morning. 11:14 in the morning, because the time is being calculated after midnight. So that is 11:14 a.m. of the day. So that's all about question number 8 from the May 2024 P2 paper. Fine.